All right. Let's see. Today we're going to go over 7.4. This will be the last new section of the textbook we go over. Wednesday we will do our in-class review. I have already uploaded questions to Scholar for the in-class review. I strongly recommend you look at them before Wednesday to get a feel for where you stand with the sorts of skills you'll need for the final exam. If you have additional questions, you should bring them on Wednesday. The final exam is Friday in this room at 2 o'clock. Let me check the schedule to absolutely confirm that. Yeah, Friday in this room, 2 o'clock. There will be a tutor-led review for our exam. I believe it's tomorrow night. I sent the link around about a week or so ago. Questions? Yes.
So for the, I couldn't see the homework that Attorney Post was available on Scholar anywhere. Are you turning somewhere else?
I'll open up the link on Scholar for homework and make a specific request. Ask that question again on Wednesday if it's not there. It should be there. Right now, worry about the exam. I mean, because, I can make the homework due, a week from Wednesday if we need to. So worry about the exam. That is your proximate concern. Also, I should mention there are IDEA evaluations for the class available. The more people that fill it out, the better. They really ought to give us like a prize or something, like a free pizza, if we can get 100% participation. Maybe they should give you free pizza. That actually might be more motivating. Anyway, so fill it out. Comments about my fedora are always welcome, pro, con, or otherwise. All right, 7.4. So like the more complex proofs, we're going to talk a little bit about more complex reputations. And more complex reputations essentially work like this. They're going to require multiple assumptions, and that's how they're similar to more complex proofs. But like all reputations, we're going to be using it to demonstrate the invalidity of the argument. So we're going to use the truth assignment test as part of this. So we'll be setting the truth values of the premises to true and the value of the conclusion to false. And the goal of the assumptions and the inferences will be to find assumptions for the letter values, which are ultimately compatible with the invalid set of values. So, for example, if we take this problem from 7.4, two premises and a conclusion. If A, then both F and P. If not A, then N. From that, we want to demonstrate that P does not follow. Again, like with the simpler versions, when I tell you this is a refutation, what I'm communicating is that this is an invalid argument and that the conclusion should not follow from the premises. All right, so let's try to do some steps up here on the board. So if A, then both F and P. If not A, then N. P. And ultimately those premises will be true, the conclusion will be false. Who can tell me what the first step of the refutation will be?
Would we find the opposite of
Good. Step one in all of chapter 7 is we will always begin by assuming the opposite of the conclusion. So the conclusion's P, we will start by assuming not P. All right, but then we're kind of at a weird spot. You see why we're at a weird spot? I can't do an inference with 1. I'd either need an A or a not both F and P. I can't do an inference with 2. I'd need a not A or I'd need a not N. And this P on its own doesn't let me do anything. So I need to make an assumption. Now, when making assumptions and refutations, there are multiple right ways to proceed, but the easiest is usually to assume something that will let you break a premise. So when I look at this, I can assume A and get F and P out. I could do that. I could assume not A, and I could get N out. And either of those would be legitimate ways to proceed. I'm going to do not A, because that's going to let me do an easy inference while breaking the more complicated premise. So we'll get a 2 for here. So step 4 will be to make a second assumption. When you're stuck, you get to make extra assumptions, and we will assume not A. Then we actually have to use the not A in an inference to get in from 2 and 4. Your basic arrow rule, from left to right. Now at that point, we've used 2, we've broken 1. The definition of breaking is when you have the opposite of one of the halves of a complex statement, and you can't do an inference, or when you have the match of one of the halves of a complex inference and you can't do an inference. So at this point, we plug in the values that we've gotten, and the values we've gotten are P is false, A is false, N, and we see if we've successfully made the argument invalid, which we will discover, shockingly, that we have. All right, so P is false, therefore the conclusion is false. A is false, therefore the left half of premise 1 is false. Therefore the arrow is true because the left half of it is false. We look at premise 2. The A is false, but gets switched to true by the negation, but the N is also true, so it's true in both halves, which makes it true. This makes the argument invalid. And if we care about F, so we'll say invalid when P is false, A is false, and N is true. And if we want to throw F in, we could say when it is false or true. The reason we didn't end up with a value for F is because it's actually irrelevant. The argument is invalid whether F is true or F is false. And here's it out on the screen, if you like. Yes, sir.
So if you're assuming not P, why do you plug in 0 for P, not 1? Because if P is always 0, wouldn't not P be equal to 1?
Well, remember, this is the conclusion. This is part of the argument. So when we assume not P, the P becomes 0.
Okay.
But this is the conclusion, not a premise. So we want the statement to equal 0.
Okay.
So and we got the not from here, so we don't plug the P in here, we plugged it into the starting premises and conclusion.
All right. Thank you.
But good question. I mean, that it looks like it all runs together, and that's why the book has like clear indentations and like section breaks. Sometimes it's much harder to replicate those freehand. Other questions? You all see what I did here? You see why I did it? Yes.
So we assume 4 and 5 for the sole purpose of just proving the entire argument invalid.
Yes, you assumed the goal all along is to prove the entire argument invalid. Now note, you only assumed 4. 5 was an inference. So 4 is when we just say, let's pick something here that lets us do an inference or breaks something. But once we assumed 4, since you can do an inference, you are required to do the inference. So that gets us the value for n. And in part, that's because if you do not put this n as true, if that n turns out to be false, then this premise isn't true, and then you've got a problem. You don't have an invalid argument, and your refutation is not successful. Yes?
So before we started doing the inferences and all that, how did you decide the truth values of those 3 variables?
Oh, I just gave you a preview of what was coming. I didn't decide they were the case until I did these assumptions and inferences.
I'm still a little confused. I'm sorry.
All right, so you're wondering where I got the truth values from.
Yeah. Like before we even started doing inferences, you had those up on the screen. I'm confused where those came from.
Yeah, I was just telling you where we were going to end up.
Oh, okay.
So no, that's because this is like a training wheels starter problem. You will not, on the exam, you will not have those ahead of time. All right, we should do another one, right? Yeah, let's do another. Okay, just a reminder, when are we done with the refutation? We're done when we've used all the S&I rules possible, when every complex statement has been used in an inference, or blocked off because it's based on an assumption that's been rejected, or broken because we already possess one side of the formula or its negation, but can't do an inference. So that's how we know when we're done with these. Let's do another one. All right. If A then B, if C then D, if F then C and D, therefore if E then C. Okay, what do we do first?
Assume the opposite of the conclusion.
Good. Conclusion is if E then C. We'll assume if it is not the case of if E, then C. All right, somebody else, what do we do next?
You're gonna have to make an assumption. Because you can't really-
We don't need to make an assumption yet.
No, you can break those down.
Good. So we break it down. We break it down. How do we try to break it down?
S&I rules.
Good. So where can we use an S or an I rule?
We can use it on number 4.
Excellent, yes. So we can't do anything with 1, 2, or 3. These are all arrows, straightforward arrows. So we either need to match the left or have the opposite of the right. We don't have any of that. But if you look at 4, that's a negated conditional. Negation is outside the parenthesis. That means we can use the negated if then rule. And we can infer out the match of what's on the left, which is E, and the opposite of what's on the right, which is not C. And those are both from line 4, negated if then. All right. And I put a little check mark because I've used 4 and I don't need to use it again. All right, but now we are stuck. Why are we stuck? Well, can't do an inference with 1, can't do an inference with 2, can't do an inference with 3. We've already used 4. 5 and 6 are just simples. So how do I decide what to do? Supposed to assume something. What should I assume? Well, sure, we will, I mean, that's usually what we do at the end, I mean, but you're absolutely right, we can do that. So, based on the fact that we're going to end up with the premises true and the conclusion false, does that help us figure out what to assume?
Try assuming, yeah.
Okay, so here's a hint. So like with the proofs, you are entitled to assume whatever you want, as long as you follow the rules. The rules are, if you assume something, you have to do inferences. If the inferences lead to a contradiction, you have to infer out the opposite of that assumption. So we absolutely can assume F. It is completely legitimate. That being said, this is going to make it a little long. This is a longer way to do it, but it's completely legitimate. So we're going to make a second nested assumption. We're going to assume F. And when we assume F, we can do an inference with F and statement 3. That will get us both C and D. From 3 and 7, the arrow rule. Now, once we got C and D, we can do, really 9 is all we need. All we need is that C out. We have to get that D out eventually if we were going to keep on in this way. So 8 with the AND rule gets us C and D. But once we get line 9, we notice something weird has happened. We have a contradiction with line 6, which causes us to block off this subproof because C in line 9 contradicts not C in line 6, and we infer the opposite of the most recent assumption. We get not F from 7 because 6 and 9 contradict. All right, so what did that accomplish? Well, that accomplished something. We got our value for F. So now let's look. We haven't yet used 1. So our next step is going to be to figure out how to use 1. 2, 2 is broken because we possess not C in line 6. So we're not going to have to do anything more with 2. 3 is now broken because we possess not F. So we don't have to worry about 3 anymore. And we used 4 when we did the S rule on it immediately. So now we're looking at line 1, and guess what we have to do? We have to make another assumption. So what should we do to work with line 1?
Assume A.
We can assume A, sure. So we'll assume A, or let's see, it's line 11, that's line 12. Line 13 will get us B, and that is 1 and 12 arrow. And then we will plug in the values. E is true, C is false, F is false, A and B are true. Note that it doesn't matter what D is. We ignore everything in this subproof that led to a contradiction. You don't use the symbols from a subproof that leads to a contradiction. And if you plug those in, this argument will be invalid. Premise 1 is true, premise 2 is true, premise 3 is true, conclusion's false. Questions about that? All right, now let me blow your mind a little bit, and let me do this again, and I'm going to do this quicker and easier. So step 4 is still the same. We still need to assume not the case if A then C. Step 5 and 6 are still the same. We still have to use negated conditional rule. When doing Refutations. The easiest, shortest way to do things is to make additional assumptions that break the premises that you haven't used yet. So we've used 4. C is 2 is already broken because we already have a value for C that does not allow us to do an inference. So we have to look at 1 and we have to look at 3, and we're going to want to assume a value for each that doesn't let us do an inference. So I'm going to look at 1, and instead of A, I'm going to assume not A. And 1 is broken. And then I look around, make sure I can't do any inferences. I still can't do any inferences. I still have to do something with 3, because 1 is broken, 2 is broken, 4 has been used. I look at 3, and I'm going to make another assumption, not F. Why am I assuming not F? Because I want to break 3, so I don't have to do any inferences. And guess what? At that point, I'm done. Bam. And I have E is true, C is false, A is false. We don't have a value for B this time. F is still false. And when you check those values, premise 1 is true because the left half is false. Premise 2 is true because the left half of the arrow is false. Premise 3 is true because the left half of the arrow is false. The conclusion is still false because E is still true and the right half C is still false. Done. I guess you might want to write out what we've proven is this is invalid when A is false, C is false, F is false, E is true. And doesn't matter what B is, doesn't matter what D is. Or to put it differently, if B is true or false, 1/0, either of those values still makes the argument invalid. So we don't need to get a value for them because it doesn't matter what the value is. Do you all understand what we did both times? And as I've been saying, both of those were 100% correct. Neither of those was incorrect. The second one was more efficient, or as I like to joke, a little lazier, because, you know, why work harder when you can work a little smarter? But neither of those was incorrect. Both of those get a 100%. All right, how are we feeling about this? Show me those thumbs. All right, we should do another one, right? Yeah, let's do another. All right. Let's do this. All right, let's work this out together. And I'll be nice to the people at home and I'll put it up on the screen. Step 1, what do we want to do? We always start by assuming the opposite of the conclusion. Like that's step 1. What do we do next? Somebody help me out. Sure.
Use S&I rules.
We want to use the S and I rules. Can we use an S or an I rule?
We can,
Yes. What can we do?
we can assume C and
All right. Well, we're going to use the negated conditional rule on 3, and we are going to infer out the match of what's on the left, C. That's from 3. Sometimes called the modus ponens rule. And we're going to get the opposite of not D or A. So we'll get D or A. Oops. Oh, wait, that's not NP, that's NIF. Okay. What can we do next? Or rather, what should we do next? Well, can we do an inference with line 1? No. We would either need a not A, or we would need an if B then C. We don't have that. Can we do an inference with line 2? No. We would either need a D, or we would need the opposite of if A then B. We don't have that. Can we do an inference with line 5? No, we would either need a not D or not A. So we are stuck. We've already used 3, so we can't reuse that. So we need to make an additional assumption. What should we assume? Did you say A?
D.
D. Yeah, we can assume D. Why not? Now, I'm going to suggest it would be easier though. So you want to assume D so that you can do this inference, right? I'm going to say that since we're doing a refutation, we don't want something that's going to let us do an inference. We want the opposite. So, I mean, D is correct. D will work, but it will take longer if we use D. So I'm going to be lazy, and I'm going to say instead of D, we're going to do not D. And when we do that, we then break 2. We will still have to do an inference with 5, but that's not going to be so bad, because that will very quickly get us A from 5 and 6, the OR rule. And conveniently, that step 7 also breaks line 1. So we look now, line 1 is broken. How do we know line 1 is broken? Because we have one of the halves of the OR, and we can't do an inference. We look at step 2, and premise 2 is broken because we have not D, and we can't do an inference with it. So we have the opposite one of the halves, but we can't do an inference. We've already used 3, so we don't need to reuse it. We've already used 5, so we don't have to reuse that. So we can be done. And we've got the values. C is true, D is false, A is true, and that will give us an invalid set of values. So A being true will make premise 1 true. D being false will make premise 2 true. And C being true makes the left half of this arrow true. And then we need this right half false. So A being true makes this OR true, which gets negated to false by this negation, which gives us true on the left side of the arrow, false on the right side, makes the conclusion false. And we're done. Now, we definitely could have used your D, and then we would have inferred out if A then B, and then we would have had to make another assumption. Eventually, we would have gotten there, but it would have taken longer. You know, I don't need, you see, you don't make inferences for values. We need to either have an inference or a break for each of the complex statements. So you don't need a final value for B. so long as when you plug in the values you do have, you have an invalid set. And the reason at the end of the day is because the B is irrelevant. So if the B is true or if the B is false, doesn't matter. The argument is still invalid. So long as the C is true, the D is false, the A is true. In this case, if you plug those values in, doesn't matter what you do with the B. Good question. All right, how are we feeling about this? Feeling a little bit better? We getting there? Should we do one more maybe? Let's do one more. Let's look at 7.4a. Does anyone have anyone in particular on 7.4a they want me to do, or should I just pick one? All right, let's look at number 3. If A, then B. If C, then both, not D, and E. Not D. And D or F. All right, first thing we do, assume the opposite of the conclusion. Then we try to do whatever inferences we can. Can't do anything with 1 or 2. 3 conveniently has the NOR rule, which gets us the negation, the opposite of each halves of the negated order. And we can put a little check mark next to 3 so we don't have to reuse it. Then we look at A, we look at 1, and we look at 2. All right, now the quickest way to get through this is to make some assumptions that will break 1 and then break 2 without doing any inferences. So I'll look at 1 and say, I don't want to do an inference, so I'm going to assume not A. The opposite will let me do an inference. And I break 1, broken. And then I look at 2, and C would let me do an inference, so let me assume not C. And now 2 is broken. 1's broken, 2's broken, 3 was used in an inference. We got values for D, F, A, and C. They're all false. So we put in false for A's, false for C's, false for D's and F's. We didn't get a value for B because it doesn't matter. We didn't get a value for E because it doesn't matter. We'll confirm with truth assignment. Premise 1 is true because the A is false. The left half of the arrow is false, making the arrow true. Premise 2 is true because the left side of the arrow is false, making the arrow true. And both sides of the OR are false, making the OR false. We're done. So it's invalid. And then if you want to like finalize it, it's best if you write invalid and you say invalid because it's not D, not F, not A, or not C, and not C. Also acceptable if you do it this way. D is 0, F is 0, A is 0. Oh, that last one was a C. C is 0. I'll do my game show bounce. Ta-da! Well, it's broken because I have a value. I can't get the opposite of the value once I have it, unless I'm gonna block off a subproof. But the value I have doesn't let me do an inference. Therefore, it's broken. It's broken because it doesn't work. It doesn't work with what I have. And I'm not allowed to assume the reverse of this once I have this. So that's what it means to be broken. It means you have the match or reverse of one of the halves of a complex statement, but no inference is possible. And it's the secret to doing complex refutations quickly. Now, I often see people on the final who can't keep their proofs and refutations straight. They start trying to break lines and proofs. Proofs don't work that way. Don't try to break things in proofs. You want to do the inferences and proofs. In refutations, you want to break them when you can.
Just to make sure, will we have our questions asking for proofs and refutations marked on the final?
Yeah, I think I can handle that. You all think I should mark things as proofs and refutations? I can be a benevolent dictator, or yeah, I can offer that.
So I'm a little confused on why we need to get the value of B and E to disprove those statements.
You're confused because we need to, or because we don't need to?
Because we didn't need to.
Right. Well, take a look at premise one. Is there any value for B that changes the fact that the premise one is going to be true?
He was, oh, never mind, that's right.
So it's the same thing with B.
Okay, that makes sense.
So here is a way that you can note it. If you make it a 1/0, that shows that you've thought about it and you realize B can be true, B can be false, doesn't matter. You're not required to use that notation, but that is a way of communicating to someone, what that means. Yes?
So is it the fact that you can't make a definitive inference about what B is the reason why you can't assume that it's true?
Well, in truth, you could assume that it's true, but that would be under the list of things that would be a correct way to proceed, but unnecessary. So you can do that, but you don't have to. Because the value of B does not matter, does not change the invalidity of this argument. There's no value for B that will make this a valid argument. So, sure, if you wanted to throw in a step here where you assume true or false for B, that'd be fine. It'd be unnecessary, a little longer, be a little more work, but it'd be okay. Now, you do want to be careful that, you do have to be careful though that you don't just assume things and then don't do the inference. So the danger would be if you assumed B was false, you would have to then do the inference right to left, which would get you the not A. But since we already have the not A, again, that would be more work than you really need. Which is why simply jumping ahead and assuming not A just saves you time. But sure, if in step 6 you assume not B, you could then in step 7 infer not A. Well, that would be fine. Be a little extra work, an extra step where you might get something wrong, but as long as you did the inference correctly and properly, that'd be okay. But it's like doing the truth table shortcut. When you learn to do it the quick way, it's usually smartest to do it the quick way. If you're not sure how to do it the quick way, then you should do it the long way and make sure you just get it right. Should I do another one of these? Yeah, let's do one more. Let's look at number 6. not A or not B, therefore neither A nor B. All right, step one, assume the opposite of the conclusion. Then we do any S and I rules. We got nothing. So here we're gonna either have to assume A, not A, B, or not B. In a certain sense, it doesn't matter, because no matter what, you are gonna have to do one inference, and it will break your remaining premise. So let's just do the straightforward thing and assume A. When we assume A, we can use the OR rule on line 1 to get us not B. From 1 and 3, the OR rule. So we've used 1 in an inference. We've got both sides of 2. 3 would break it. 4 would enable us to do an inference. So if we really wanted, we could do a step 5. But that would just get us A a second time from 2 and 4. The OR rule, so that doesn't change anything. So what we get is A is true, B is false. And then we plug it into truth assignment. Premise 1 says one of these two is going to be false. And since B is false, the premise is true. The conclusion says both will be false. And because A is true, the conclusion is false. Therefore, it's invalid when A is true, B is false. How are we doing? We good? All right. So for next time, I've already uploaded sample final exam problems to the Scholar. Check them out. Look at them. We'll talk about these specific ones on Wednesday. We'll have a little extra time at the end. Bring your questions from anywhere in the course. Now note, only the sample final exam problems will have types of questions similar to them on the exam, plus all of Chapter 7. All of Chapter 7 is fair game. So the sample types of problems plus Chapter 7. So bring your questions for that. Thank you very much. Yes, sir. No, let's keep it simple. I don't want. We do enough. There'll be a translation section, but the proofs are hard enough without making a translating first, right? Yeah. Let's not do that. All right, very good. Press forward. You're almost there. 48 hours of classes left. What's that?
Do you want to just quickly take a look at
Sure. In fact, you can keep that if you want. Yes.
Okay. I was just wondering if you could give me a rundown of what's going on with the homework again.
I'm going to open a link on Scholar sometime this week, and I'll ask for certain assignments uploaded. You most likely hand wrote them out, so you'll need to take photos. And
Well, I have them on a Google Doc actually.
oh,
Yeah.
then just send me the Google document. That's
Okay.
the easiest thing.
Sweet. But I should do that once you post it.
Yeah. Wait till I post it.
Gotcha. Okay.
It's in oral logic. Okay.
So I'm wondering if it's allowed to use a triple bar here instead of the normal.
Why? What do you want it to say?
So basically, I'm talking about like that, the thing. So I'm basically saying that, which one is,
Right.
so,
Uniforms and.
yes, my example is not even like.
Okay.
So I'm basically saying if, something does not exist in the real world, if it does not exist in the real world, we can still know things about it,
Hmm.
then it's fictional. But I'm also saying the only case in which it is fictional is the case of the truth.
Okay.
So,
So yeah, you can use a triple R in that case.
okay. I didn't know if I was allowed to use that with the modal operator.
Well, the triple bar is a stronger claim. I don't think the mobile operator affects that.
So I'm gonna check with one of my other professors, but he said that our exam for that class was 2 to 4.
On
even
what day?
though, on Friday, even though it should be, the class is from 2 to 2:50, or,
Yeah,
Yeah.
he's wrong.
Yeah, it
His
should be
exam
on-
should be 5 o'clock.
okay, I
I
thought
mean,
so.
yeah, email him and just ask him to clarify. Most likely, he just glanced quickly and, looked at the wrong column.
All right.
Very good.
Have a good day.